All right, we have the AP Statistics free response section here. This is a question from a practice exam, and we're just going to go over this question real quick. Very first thing that you need to do in an AP test of any kind is make sure that you read your directions. You will lose points if you don't do what they ask you to do in the first place. So we have to show all your work, indicate clearly the methods you'll use because you'll be graded on the correctness of your methods as well as the accuracy and completeness of your results and explanations. Translation, write down everything that you do and think. So we make sure that we get as many points as possible here. Alright, first question. Caffeine, a chemical found in many popular beverages, is known for reducing fatigue. A student wanted to investigate the caffeine content in popular beverages such as soft drinks, energy drinks, tea, and coffee. The following data collected by the student showed the amounts of caffeine in milligrams per 12-ounce serving for 12 popular beverages. So we have our data set right here. First question A. Construct an appropriate graphical display of the amounts of caffeine found in the 12 beverages. Alright, so thinking about our data set here, we have one variable, that's the milligrams of caffeine per 12-ounce serving, and we're talking about a nominal or countable data set, and we can use then a histogram. We could consider boxing up the data into equally spaced repetitions, or we could use a box and whisker plot, which actually gives us a little bit more information about this data. So let's go ahead and start to construct here a box and whisker plot. In order to do that, the first thing we need is to organize our data. So I'll go ahead and do that. Alright, now that we've ordered our data, we need to find the median, the first quartile, and the third quartile to make our box and whisker plot. And we do that by taking equal numbers on the amount of numbers on the left and an equal amount of numbers on the right. So if we count 1, 2, 3, 4, 5, 6 here, and 1, 2, 3, 4, 5, 6 here, right here in the middle between 45 and 55 is our median. So because we have an even number of data points, we need to find the average of those two numbers that are kind of straddling the line where the median is. And we do that by adding them up and dividing by the total number we are adding together, which is 2, and that gives us 50 is our median. Then we need to find our first quartile. We do this the same way as we find the median, only we split it right down the center and then find the median of the first half of numbers. Same idea, we have 6 total numbers, so our median is somewhere between the third and the fourth number, so we need to find the average of those two, which gives us a 36.5 is our first quartile. And then the same thing for the second half. We have 6 numbers, so right here in the middle we split our numbers down the middle 2 ways. An average of 72 plus 80 over 2 gives us 76, which is our third quartile. Alright, now we're ready and we have enough information to draw our box and whisker plot. And we start with only one variable here, which is our milligrams of caffeine in a drink. This is a nominal or countable data set. And so we start by drawing our axes for the box and whisker plot. Down here on the bottom we have milligrams of caffeine with my beautiful tablet handwriting. And we will start by picking out maybe an appropriate window or interval to display on the graph. So why don't we do 50? Sounds pretty good to me. We'll start with 50 milligrams here, 100 here, and 150 here. Alright, so the first point in the box and whisker plot is our lowest number, which is right up here, 7.5, the bottom of our range, somewhere way down here. We have this data point. And then we draw till our first quartile right here, and we draw a line that's at 36.5. I'm going to say that's about right there. And we connect those two suckers. Then we draw another line in the middle of our box at our median, which is 50. So we'll draw a line right there. And our third line is the Q3, our third quartile, which is 76. And that's about halfway between these two, about right there. So this part right here makes up our box for the box and whisker, and I'm drawing on a tablet so my box isn't that pretty. But then we need to draw the final data point right here, which is 165. That's way out over here. And usually we would consider this 165 to say, wow, that's so far past our box and whisker plot that it's an outlier, so we can just kind of put it right here, and then we will draw our 105 about right there. Here we go. So we need to explain a little bit why we drew our 165 as an outlier. The official rule for a box and whisker plot is that you take your third quartile, we'll label these here. This is our third quartile. You take your third quartile number, which we have up here as 76, you multiply it by 1.5, that gives us about 110. And if the number is past 1.5 times the third quartile, then you are an outlier. So 105 right here is barely inside, so it's almost an outlier, but 165 is definitely an outlier, so we draw our box and whisker plot like this and count this one as an outlier. Alright, so that completes question number 1. Let's take a look at our question letter A. Let's look at letter B now. It says, use the graph in part A that we just made to write a few sentences describing the distribution of caffeine content for the 12 beverages. So let's talk about distribution. When you say distribution, that's talking about the shape of the data, how it looks, how it's spread out. There's a few ways to talk about it. So our first way to look at distribution is through what are called measures of central tendency. We have things like the median or the mean or the average that tell us where the data tends towards the center. Our median is 50, so we know that our central tendency measure is 50. We can next look at kind of a measure of spread. So we have central tendency, we have spread, which measures how far apart the data is. The thing that we have on this box and whisker plot that shows spread is our interquartile range, represented by the distance from quartile 1 to quartile 3. Or even the range right here, throwing out this outlier over there. These are two ways to look at spread. The third is the shape of the distribution, which is represented by kind of how it looks when it's spread out. We have a little bit of a skew to the right here. Our right-hand side of our box and whisker plot is bigger than our left-hand side, which means that our data is skewed to the right. And this is because of our big outlier here and this number right here, which is almost an outlier. So our data has more skew to the right-hand side as well. Alright, so that answers question B. Let's go to question C. A 12-ounce cup of one popular gourmet coffee contains over 300 milligrams of caffeine. If this value was added to the data set of 12 numbers above, how would the mean and median of the data set above compare with the mean and median of the new data set with the 13 numbers? Explain how this comparison could be made without performing any computations. I like that phrase because we don't have to perform any computations. Great! Less math to do. Okay, not that math is bad, but it's less work for us. So let's talk about how we could compare that. We have mean and median of this data set that we started off with. And then if we add a massive outlier of 300 milligrams of coffee to the data set, we want to look at what that does to the mean and median. So our first data set, the mean and median, we have somewhere in the area around right here. It's a measure of central tendency. If we were to add another point that is 300, I'll have to zoom way out to get it to the 300 level. Let's say that it's somewhere way over here. Our 300 milligram point of caffeine, also an outlier, of course. Then we change the mean significantly. Outliers really change the mean around, so the mean would move somewhere closer to over here. But the median, since we found the median by finding the middle of an ordered set of data, the median wouldn't really change very much. In fact, we can just look at it. First we were looking between these two. Now that we have an odd number of data points, we don't need to find the mean between two numbers, so our new median would be 55 right here. So it didn't change much at all from 50 before. That answers question C, and we are done with this practice response, free response section of the AP test. I just want to make a side note that anytime you are on an AP exam, especially when it has to do with free response questions, it's a good idea to make sure that you don't spend too much time on one question. If you're stuck, you get done with the first part and you don't quite know how to do the second part or the third part, then just move on to the next question and start working on that and get as many points as you can. Once you've completed some of the other questions, or you have to skip some more because you get stuck again, you come back to this question at the start, and then you're able to get more points that way on the exam. Thanks for watching. I'll see you in the next video.